Hello. In this video, I'm going to go over section 2.2, which is about limits. And it's important that we talk about limits first in calculus because it's probably the most important concept in calculus. Okay, so in this section, we're going to introduce this idea of a limit, and then we're going to talk about the various ways of finding limits. Okay, so to illustrate this idea of a limit, I'm going to look at this third example. So suppose we have this function here, x cubed minus 8 divided by 4 times x minus 2. What we're going to try to determine is what happens to the y value for this function as the x value gets closer to 2. And we're going to do that by creating a t-chart or table. And that's one way of finding a limit, by the way. So in this t-chart, what we're going to do is we're going to approach x from the negative side of 2, or that's also called the left side of 2. And when you do that, you can see that for these x values that are getting closer to 2 from the left side, the corresponding y values, when you plug them into the function, these are the corresponding y values, they appear to be getting closer to 3. And so this is called the left side limit of the function as x approaches 2. And that limit appears to be 3. Okay, and that's called a one-sided limit. Now you can also approach 2 from the positive side of 2, which would be what's happening here in this part of the table. Okay, that's called the right-hand side limit. Okay, because you're approaching from the positive side of 2 on the number line. And so in this case, this one-sided limit is also, it appears to be 3 as well, right? The y values are getting closer to 3 as these x values are getting closer to 2 from the right-hand side of 2, or the positive side of 2. So we have two one-sided limits here. The left side limit appears to be 3, and then the right side limit appears to be 3 as well. We also have this notion of what's called a two-sided limit. The two-sided limit is what happens to the y value as x approaches 2 from both sides of 2. And if that number is the same from both sides, which it is here, right? They're both approaching 3. So if the left side limit and the right side limit are the same number, then we say the two-sided limit is equal to that number. So in this case, the left side limit is 3, the right side limit is 3, and therefore the two-sided limit as x approaches 2 is also 3, because those numbers are the same. Now, if those numbers are different, if the left side limit and the right side limit are different numbers, then the two-sided limit does not exist. And we'll talk about that in an example later on. Okay, but in this case, the left side limit and the right side limit are the same number. They're both approaching 3, so the two-sided limit for this function is also 3. Now, in terms of notation, the way we denote a limit is we just write LIM, and then we write the function that we're finding the limit for next to it, and then below the limit, we write what x is approaching. And in this case, we use the superscript with a plus sign. That indicates that it's approaching 2 from the positive side of 2. In other words, the right-hand side of 2. So this is asking for the right-hand side limit as x approaches 2. And of course, it's equal to 3, as we saw in the table. Okay, to denote the left side limit, you would just put a negative superscript here. So this means what's the limit, or this is asking for what's the limit of the function as x approaches 2 from the negative side of 2. And then for a two-sided limit, we just don't put a superscript on the 2. So this is a two-sided limit. And so it's asking for what is the y value of the function approaching as x approaches 2 from both sides of 2. Okay, in all three cases, though, we found the left side limit and the right side limit to be 3, so this two-sided limit is also 3. Now, we can also have done this graphically, right? So one way of finding a limit is to create a table like we did down here, but you can also look at the graph of the function. So the graph of this function looks like this. It actually has a little bit of a hole here in it. That's because when x is 2, if you plug 2 into this function, you get 0 over 0, which is undefined. Okay, so there's actually a hole in this little graph right here. Now, so let's look at the graph and try to find the limit using the graph, because that's another way of finding limits. So what we're going to do is we're going to approach 2 from the left side of 2. And so you can see for this particular x value, the corresponding y value is right here. And now we're going to get closer to 2. And as x gets closer to 2, I think you can see the y value is getting closer to 3. So that shows us that the left side limit is 3. And now we're going to approach from the right side. Okay, so for this particular x value, there's the corresponding y value. And as x gets closer to 2, you can see that the y value is getting closer to 3 from above 3. And so that shows that the right side limit is 3 as well. And of course, that means the two-sided limit is 3, since the left and the right side limit are the same number, 3. Okay, so you can also look at the graph of this function to determine the limit. Okay, now let's look at this fourth example. So in this example, this is our function g of x, and we want to determine the left side limit as x approaches 1, the right side limit as x approaches 1, and then the two-sided limit as x approaches 1, if they exist. And we're going to find these limits by looking at the graph of this function. Now, if we wanted to, we could have created a table as well. Now, the advantage of a table is it's more precise, but the disadvantage of a table is it requires more calculations. If you have a graphing calculator, you could also just graph this and look at the graph, although sometimes the graph is difficult to tell precisely what the limit is. But in this case, I think it'll work. So here's the graph of that function. It's a very bizarre looking function because it's not connected. But nonetheless, this is the graph of this function here. One of the reasons this graph is unusual is because of this absolute value of x minus 1. Okay, so we're going to try to determine the limit as x approaches 1 from the right-hand side. And so if you're on the right-hand side of 1, then the y values that are coming out appear to be, as you get closer to 1, they appear to be getting closer to negative 2. Now, one way of looking at this is if you're on the right-hand side of 1, then these are the ordered pairs that you have as you're getting closer to 1. Okay, so look at these ordered pairs and try to determine what the y value for these ordered pairs is getting closer to. And I think you could see that the y value for these ordered pairs is going to get closer to negative 2, which is where this hole is at. Now, if you approach from the other side, from the left side of 1, all right, so you're plugging in numbers like this, and then you're getting closer to 1, I think you can see the y value is getting closer to 2. Okay, another way of thinking of it is if you're approaching from this side, then your ordered pairs are here on this path, not this one. And just look at the y values that these ordered pairs are getting closer to, and I think you can see that the y values for those ordered pairs are getting closer to positive 2. So this is a case where the left side limit and the right side limit are not the same number. The right side limit is negative 2, whereas the left side limit is positive 2. And so when that happens, when those aren't the same number, then your two-sided limit does not exist. Okay, so I guess the answers in this case would be from the left side limit would be 2. The right side limit is negative 2. And then this two-sided limit doesn't exist since the left side limit and the right side limit are different numbers. Okay, so in this section, we've talked about two different ways to find limits. One way of finding limits is to create a table. Another way of finding limits is to look at the graph of the function. And then later on in chapter 2, we'll talk about another way that we can find limits. And once we learn how to find limits using that other method, it's called the substitution method, then we will primarily use that method to find limits because it's the most accurate and most convenient way to find a limit. Okay, as I mentioned, finding a limit using a table is fairly accurate, but requires a lot of calculations. Finding a limit using a graph is very convenient, but doesn't always give you a precise answer. It depends on what the graph looks like. But the substitution method, which we'll learn later on, is a combination of both. It's very convenient to use, it's not very tedious, and it's also very accurate. Okay, but we'll talk about that later. Okay, I hope you found this video helpful. Thank you for watching. Bye-bye.